In this video, we're going to talk about solving right triangles with just a couple of examples. Okay, so recall that we have already discussed all of these trigonometric ratios. Sine of theta equals opposite over hypotenuse, cosine of theta equals adjacent over hypotenuse, tan of theta equals opposite over adjacent, and we've already discussed the reciprocal functions, cosecant, secant, cotangent. Make sure we always keep in mind what angle we're using, as so we know whether we're looking at the opposite side or the adjacent side to that specific angle. Okay, so here's our first example. We want to solve all values of the triangles using the trigonometric functions. Okay, so the first thing I'm going to do, since here angle D is given to be 30 degrees, angle E is given to be our 90-degree right angle. The only angle that we don't know is angle F, so the first thing I'm going to do is solve for angle F. Recall that the sum of the angle measures of a triangle has to equal 180 degrees. So I can use this and say 180 degrees has to equal our 90-degree angle plus our 30-degree angle, and the angle that we don't know, angle F. So solving for F, I'm going to get F equals 60 degrees. Okay, the next thing I need to do is I need to solve for either side D or side F. Here I'm going to choose to start with side D. So keep in mind, SOHCAHTOA. So if I'm going to start with side D, and I'm going to use angle D, 30 degrees. So here I have 30 degrees is opposite of D. So I need to use sine. Sine of 30 degrees is going to equal opposite, which is D, over my hypotenuse, which is given to be 6. Solving for D, I find that D equals 3. Okay, next I need to solve for side F. I have one of two options. I can either use cosine of 30 degrees. Cosine is adjacent, which is side F, over hypotenuse, which is 6 degrees. Solving for F, I'm going to get 3 root 3, or I can find side F by using the Pythagorean theorem, a squared plus b squared equals c squared. Here I already found side D, which is 3. My other side length is side F, so I'm looking for F squared, equals C, my hypotenuse squared. So I'm going to get 9 plus F squared equals 36. F squared equals 27, or F equals 3 root 3. So as you can see, I get the same answer no matter which way I go. So it's really up to you on whichever method you're more comfortable using. Okay, in this next example, it's given that B equals 56.5 degrees, and little c, which in this case is our hypotenuse, equals 0.0447. So again, the sum of the angles of our triangle has to equal 180 degrees. So I'm going to have 90 degrees plus 56.5 degrees plus angle A has to equal 180. So angle A is going to equal 33.5 degrees. Okay, now that I have all of my angle measures, I'm going to focus on trying to find the side length of little a and little b. So if we have SOHCAHTOA, I'm going to use angle A, which we just found, 33.5 degrees. So I can have the sine of 33.5 degrees equals opposite which is A, over my hypotenuse, 0.0447. Solving for A, I'm going to get 0.0, I'm going to round to the nearest hundredth, 2. Now we need to find the length of side B. So with side B, I can use cosine of 33.5 equals adjacent, which is B, over my hypotenuse, 0.0447. Solving for B, I get 0.4. All right, in this last example, we're given angle R, 26.7 degrees. Angle S is our right angle. So again, we need to solve for angle T. So solving for angle T, I get 180 degrees equals 90 degrees plus 26.7 degrees plus angle T. Solving for T, I get 63.3 degrees. All right, in this case, it did not give us our hypotenuse. Our hypotenuse in this case is represented by little s. It gave us the side opposite to angle R. So if I use SOHCAHTOA, I need to use the side opposite. So I'm going to have sine of 26.7 degrees. Opposite is our 0.17 divided by our hypotenuse, which is what we're solving for, little s. Solving this, we're going to get little s equals 0.38. I'm going to round to the hundredth again. Okay, now we need to solve for little t. I can either choose to use cosine of my angle R, or I can choose to use the Pythagorean theorem. So in this case, I'm going to choose to use the cosine of 26.7 degrees equals my adjacent, which is side t, over my hypotenuse, which we just found, 0.38. Solving for t, I get 0.34. Note that I also could have chose to use tangent here since I already have my side opposite and I'm looking for my side adjacent. So we could have chose to use any one of those three methods. And that's really all there is to solving right triangles.